A neural network's answer is a function of a function of a function. Data goes in, passes through layer after layer, and comes out the other end as a prediction. And then a loss, a single number saying how wrong it was. Training asks one question. If I nudge one weight buried deep inside that stack, how does the loss change? One rule from freshman calculus answers it. The chain rule. Forget slopes on a graph for a second. A derivative is a sensitivity. Twitch the input by a hair, and the derivative tells you how hard the output flinches. Every piece of a network, every multiply, every activation has its own local sensitivity. Cheap to compute and known in closed form. Now compose two functions. Feed G into F, twitch X, and G flinches. That flinch feeds F, and F flinches in turn. The sensitivities multiply. That's the chain rule. The derivative of F of G is F prime times G prime, gears in a gearbox. Each stage multiplies its ratio onto the last. A network is just a long gearbox. Multiply by weights, add a bias, squash with an activation, repeat 30 times, 100 times, and score the result with a loss. The forward pass computes the prediction and leaves breadcrumbs behind. Every intermediate activation saved for later. Then the signal turns around. Start at the loss and walk backward, multiplying each layer's local sensitivity as you go. Each step peels one function off the stack. By the time the wave reaches a weight, every ratio along the way has been folded in. That's backpropagation. The chain rule. Industrialized. And here's the beautiful part. At every layer, the arriving error signal meets the activation saved on the way up. Multiply them together, and you get the gradient for every weight in that layer at once. One matrix multiply. Millions of partial derivatives for the price of one forward pass and one backward pass. Compare that to the naive way. Wiggle a weight, rerun the entire network, watch the loss, and repeat once per weight. A million weights means a million forward passes for a single training step. Backprop does it in two. That efficiency is not a detail. It is the only reason deep learning exists. So when a model learns to see, or translate, or talk, under the hood, it's freshman calculus, ticking backward through the stack, layer by layer, billions of times a second. One old rule compounded into intelligence. That's how the chain rule trains neural networks.